Well, you can help me put the stripper on.
What's a stripper?
Hey, it's Pete. Welcome back to the workshop. This week we're heading back outside again to continue the work on our vintage Carnival ride restoration project. So this week I am tearing into the drivetrain, going to pull the motor and the right angle gearbox and the chain and check into the central shaft, see what it's going to take to try to pull that out and inspect the bearings. I know there's bearings at the bottom. I'm not sure about the top. There's a lot of slop up there. Pulling the motor is a good project for me right now this time of year because the weather is still a bit iffy. You never know from day to day if it's going to be 70 out there or 30. And the motor is something I can pull and bring here into the shop and tear it apart, replace the bearings, and just get a general look at it and make sure that it's up to snuff.
So in trying to pry this fan off, I did crack it, but based on the scratches that are in here, I'm going to say that I was not the first person inside of this. And we do have some fins cracked, so I couldn't let that slide anyways. I'd have to replace this.
Future Pete stopping in to say that that statement is going to come back and haunt me. Stick around and find out why.
All right. Well, if it had a key, it spun. So since I can't get the centrifugal clutch off the end of the motor shaft, what I'm going to do here is take off the bell housing for the rear of the motor, which I need to take off anyways because I want to replace the bearing in there. Once I have that off, I'm going to set the motor vertically in my press and then try to push the arbor right out through the centrifugal clutch. And we've got our switch for the capacitor. Okay, the idea here is to put this on the press vertically. See if we can't push the shaft down through. There we go. It's going to get heavy real quick, I think. Well, we got this loose enough now that we can get this off. There we are. We're just a little too short. Kind of curious to see how they have this hooked up. I see we've got a white, a black, and a red wire. I don't see any signs of wire nuts, so I'm curious how they have this actually connected under here. They just twisted it together. Nice. 1, 3, and 8. I do have to say, for just being twisted together, they're holding on remarkably well. 4 and 5. 2, 4, and 5. Is that it?
I spent a bit of time cleaning up the nameplate with some Q-tips and isopropyl alcohol. That was able to get most of the yellow paint overspray off without damaging the original markings. I figured the easiest way to clean up the rotor and shaft was just to chuck it up in my lathe and go at it with some emery paper and Scotch-Brite. I just had to watch out for the spinning fan blades of death. While it was spinning, I noticed there was quite a bit of wobble in the fan, so I used my tool post as a makeshift gauge to set all the blades at the same spot. While I had it chucked up, I also tested the operation of the centrifugal switch for the starting capacitor. My lathe tops out at 1800 RPM, and that is just enough to trip the weights.
I would imagine with the way this looks that this, when it's originally assembled at the factory, slips right in there and clicks in place, but with some age this is probably brittle, and I doubt that I can get that off of there and get it back on without cracking it, and I bet that I can't get that part. So I'm going to leave that well enough alone, just clean off the oxidation on these weights, and we'll call it a day. I'm going to try to use the evapo-rust on it and see if that takes care of it. It's definitely working.
I had to order a larger bearing puller to get the reach I needed to get to the front bearing on the motor shaft. Unfortunately, these fingers are just a little bit too thick to fit between the bearing and the internal fan that's inside the motor. It is a double-ended puller, however, and both ends are the same, so I'm going to spend some time on the bench grinder and see if I can't thin these out to get me the clearance I need.
So here's my freshly ground tips for this bearing puller. As you can see, the other side is quite a bit larger. Hopefully I'll be able to get these in here between the fan and this bearing. Do believe we've got it. Lovely. Snap ring on here to set the position. The bearing can't go on too far. Just a little crunchy. We have to get all this old paint off of the motor.
Okay.
But in order, before I take the old paint off,
Yeah.
I don't want to ruin this label that tells us all about this motor.
Okay.
So I'm going to cover it with tape first.
Okay.
And then once the tape is on there, we're going to cut around it.
Am I going to just sit here?
Help me put the stripper on.
What's a stripper?
That is the chemical we put on to take the paint off.
Oh.
But we have to get this part done first.
Yeah, cut it. Yeah.
Okay.
Cover this.
No, I think we can tuck that up inside.
Let me try.
Yeah.
Yeah, we probably can.
Okay. It smells like oranges, doesn't it?
Yeah.
Okay, go ahead and spread that around. Tell you what, I'm going to get a brush too and help.
Shall we do some of the wires?
No, we don't want it on the wires.
Or it would not work?
Yeah.
Okay.
Alright, did we do good?
Yeah. That looks perfectly.
Let's get some done here too.
Yeah.
Can you hold this box for me?
Yeah.
Just like that. So that I can pull this out. Now we're going to cover this.
Did you buy this or did you get it from side?
I think Nanny bought that.
For you?
Well, no, it was for inside, for in the kitchen.
Oh.
And then, but I needed it out here. It's got to sit all night, and that'll take the paint off.
Okay, and then in the morning we have to check.
Yeah, well, probably not till tomorrow night.
Oh, yeah.
So I made a bit of a mistake when I was pushing that centrifugal clutch off the motor shaft. I allowed the internal fans to go down too far, touching the motor windings and scratching some of the insulation off. Now, in my opinion, with the way this happened, I don't think that it's ever going to cause a short circuit. It is a weak spot, though, now where moisture can get in under the insulation, causing corrosion and a possible future failure. Fortunately, I have some motor varnish on hand. I'm just going to go in there and use this to touch those spots up. With everything cleaned up, it was time to start putting this back together. I decided to stick with the original starting capacitor. This is something that either works or it doesn't, and since this is a good quality Philips brand capacitor, I figured it was better than some readily available no-name brand capacitor. It's an easy fix in the field if it should fail, and I have one on hand in the event that happens. Spoke too soon, slight detour here. I totally forgot to clean up the nuts and bolts that hold the motor together. Quick soak in the evaporust, a rub down with some Scotch-Brite, and then chase the threads.
I am gonna say that's a 1032. 1032. Okay. There we go. I want to go check the replay and see which way the bolts were originally inserted. I'll be right back. This is one of the best reasons for making videos. If you don't remember how something goes together, you can always just go back and look at it. And in this case, I was right. The nuts are on the front. Now these nuts are actually serrated on both sides, so it doesn't matter which way you put them on, they'll dig in. Slight rubbing, but that's the contacts rubbing against the switch back here. Once it gets up to speed, those will drop out. Well, I do believe we could put a cheater cord on this. and fire it up. Alright, we got a little quick cheater cord hooked to it. And I guess this is the moment of truth. Let's see what she does. I am really not liking the sound of those front bearings. We may have to pull those and put different ones in. I'm cleaning this keyway out just for thoroughness. It's actually not used. There's a key slot back here that's actually what is used on this application.
So I woke up to a bit of a surprise this morning that makes me think that maybe things are starting to get back to normal. Yesterday afternoon, I determined I was not happy with the way this front bearing sounded, so I hopped on Amazon and I ordered a new one. Now, I got a slightly different bearing. The original bearing that I had ordered had rubber seals on each side. I went with metal shields this time, which was closer to what the original bearings had, and placed the order. They were to arrive this coming week. Unfortunately, I am leaving town tomorrow, Monday, for Houston, and I'll be gone all week. So the bearing was going to be arriving, I was going to be leaving, and I would be in the back of my head all week long wondering if that was going to fix the problem. Well, according to tracking, that bearing is being delivered this afternoon, so I'm going to be able to throw it in there before I leave town and at least know whether that fixes it or not. I had some concerns that I might have damaged the original bearings when I installed them. I didn't expect it to be a very tight fit, so I pushed from the outer race rather than the inner race. With this new bearing, I took a bit more time to find some suitable spacers, in this case a large socket, to make sure that I was putting the force on the inner race.
That sounds a lot better.
Final step was to reassemble the centrifugal clutch. I really don't know much about these. My only experience with something similar is on a go-kart when I was a kid, so I don't know how to tell if there's excessive wear or they should be replaced. I'm assuming this is something I'm going to learn going forward.
Alright, these are the original crappy things that held this on. I guess this clutch is probably not something you're supposed to run without a load on it.
So I have a little bit of a problem, and you might suspect what it is because I know it's been in the back of my mind. When I pulled this motor apart and determined that some of the fins on the fan for the cooling fan on the back of the motor were cracked, and I said we would just get a replacement. Well, Grainger does not have a replacement for this fan. It's a Dayton motor, and they do not sell a replacement fan for this motor. Now, to me, that's just a little bit ridiculous to have to scrap a $300 to $350 motor because of a $10 to $15 fan. So here's my thoughts. I don't need this motor for quite a while. I mean, I don't know how long this project's going to take, but it's going to be a while till we're ready to actually need the motor running to make the ride run. So we have time, and I suspect somewhere out there in the world, there's a whole shelf full of these fans just sitting there waiting to be put on motors. And if you know somebody who works in a motor factory that builds motors that get put under the Dayton name, I don't know if they're Marathon or WEG or Leeson or who makes them, but obviously somebody makes them, and those fans have to be available. So if you know somebody, I'm going to put the specs of that fan down in the video description along with the motor number, just in case somebody happens to be scrapping out a similar motor that we can just pull the fan from that. I have to believe that we can find a fan for this motor. So I am going to leave this motor in primer for the time being. It's protected from rust, and I don't exactly know what color I want to make it, and I'm probably not going to know that until I actually pick colors for the ride itself. So for the time being, this is just going to stay gray, and we can move on to something else. If you like projects like this, click that subscribe button down below, then follow along each week as we work on this project. And if you want to catch up with the project, click one of those links to the left, and I'll catch you over there.